Good morning. Thanks everybody for coming. I really appreciate the fact that this room is almost full, even though it's the morning after the after party. It's very generous of you, honestly. So welcome to Operating Rails. This talk is kind of, well, I guess it's got multiple purposes. So it's an introduction to deployment and operations if you're newer to building Rails apps, but it's also my best efforts at constructing a framework for how to think about deploying and operating web applications after 20 years of trying to do that and having to figure it out for myself, right? What needs to be covered when you're going to production the first time, what needs to be covered when you're going to production for the 1000th time, and how do you think about those things as you keep having to do them over and over and over throughout your career. So before we get into those details, I'll introduce myself a little bit, right? I'm better known as Indirect on the internet, and as Cameron mentioned, I worked on Bundler and helped create it way back in 2009, and then worked on the Bundler and Ruby Gems teams, making all of the, make the spice flow, make the gems flow, whatever, for about 15 years, and more recently I've been working on a project to create kind of like a community-driven gem server at Gem Co-op. I built my first Rails application in 2004, and trying to get that application off of my laptop and to where other people could see it, right? It was amazingly easy to build, and then it was amazingly not easy to get other people to be able to use it. And that is actually what I would say started me down the path to DevOps and madness. And I have learned many things from 20 years of watching Rails apps break in production, so let's talk about that. So, set the scene here, right? An excited Ruby developer follows a Rails tutorial. Maybe they have a blog, maybe they have a to-do app, maybe they made up their own super cool thing. They walk through the codes, the tests, the features, they finish the tutorial, they have a whole thing, and then they think, wait, how do I show someone else this thing? Shoot, okay, maybe I'll just go find a tutorial from a hosting company, right? Like the tutorial works so great for Rails. And then you go to Heroku or Fly.io or Railway or DigitalOcean or something. And maybe if they're not that helpful of a tutorial, they tell you to look at AWS or GCP or something. But no matter what service they suggest, now you need to find another tutorial and you need to follow that tutorial, and then that's a whole new problem because every tutorial for deploying things says, and of course, this tutorial isn't production ready. And that's, all these tutorials, they just kind of like wave their hands and they're like, don't worry about secrets, databases, backups, alerts, we can't fit all of that in here. This is a tutorial. And so, honestly, I'm not really sure how we as an industry expect people to figure this stuff out if they don't already know it. But that's what I'm trying to cover in this talk, and that's kind of like the conversation that I'm hoping we can have more of over time in the community. So, this hypothetical Rails developer follows a tutorial. Maybe they have a shiny new application and database on Heroku, and now the actual problems start, right? Like, where are the secrets? Is there a backup of the database? What happens if there's an exception? How do I debug this thing? So instead of trying to literally answer each of those individual questions, which I'm sorry, I love all of you, but none of us have enough time to do that. So instead, I'm going to talk about a framework for thinking about production applications. So whether this is your first deploy or your 100 production service, there's like a set of problems that you need to think about and you need to make sure you have a plan for as part of operating the service. So the goal, the framework, everything that we're going to talk about today all goes up into this idea of confidence. If you are operating a service, what you need is not a service that works perfectly 100% of the time, because that is literally impossible. What you need is confidence, not just that your service mostly works, but confidence in how you're going to handle the problems that crop up while you run your service. And that means you need to have a plan. And so that confidence isn't just yours, it's also confidence of your coworkers in the whole system that's running. It's confidence of your downstream end users that your application is working correctly and is going to be there when they need to use it. And so we're going to talk about the factors that contribute to that highest level confidence idea. And so the 5 categories that I have landed on after all of this kind of like working through this is errors, data, speed, security, and lead time. Lead time is the amount of time it takes for a change to go from committed to live in production. And shorter lead time can be absolutely amazing to help you with all of the other categories. But we're going to talk about more about it towards the end. So let's start with errors, right? Conceptually, an error is any time someone isn't able to use your site. It doesn't necessarily mean an exception report, but it does mean, like something didn't work. And so it could mean your Ruby code threw an exception. It could mean you shipped a new configuration file with many duplicate entries in it and the entire internet went down if you are Cloudflare. It could mean that, I don't know, a truck ran into the pole outside the data center and now your servers are gone. That happened to me once. Oh, man. So with that in mind, how will you know about the error is actually the first problem. Like you're starting to think about how am I going to handle these errors? Well, the first problem is how are you even going to know that there was an error in the first place? How are you going to be confident about handling it? And so this is not common advice in deployment talks. I think it should be. Actually testing things is the first step to operating them in production. Test it manually, test it automatically, have other people try it and tell you if it worked for them. All of those things will save you more production debugging time than you can imagine. I swear it. Every time I convince myself this time it'll be different, I am wrong. And then another really popular and effective way to increase confidence in your production deployments is to have a staging deployment where you put it first. And you can test it and make sure it works there before you put it into production. Rails, as a framework, pretty handily has like built-in intrinsic support for multiple environments, which at the time was really cool, right? Today you're like, oh yeah, everybody has staging, blah, blah, blah. But at the time we were like, wow, built-in support for staging, that's very cool. Anyway, once you've used staging, once you've tested it, once you have higher confidence, right? We're going back to the confidence topic. Then you can promote those changes to production. If you have a cool platform, maybe there's just like a button and you don't even have to create a new container, image, deploy, whatever. It just like copies it directly into production, and that's cool. Once you have those manual and automatic tests and staging and production, the next most common set of strategies is having exception reporting and uptime monitoring. And exception reporting does exactly what it sounds like. It sends a report when there's an exception. Uptime monitoring is just some other server that you don't own sending requests to your server and saying, hey, did that work? And I suggest for those needs, I suggest starting with either Honeybadger. Josh is around here somewhere at the conference. Say hi if you see him. Or Sentry to set up exception tracking and uptime monitoring. They're both free for a single user, which is great if you have a personal project. Like I have a Slack where all of my personal projects live and they each get a channel, and then I connect the reports to the channel for that project so I can be like, oh, something's going on with that project because of, or it went down, or there was a Ruby error, or whatever. Kind of like moving down the stack, the next thing below uptime monitoring is like observability. Sometimes gets called instrumentation. The most basic level of that is just, here's the logs from your app. Nowadays, most platforms provide that, which is also great. Like you can just deploy and they're like, here's the logs. And I'm like, wow, I didn't have to build anything to see those logs. That's so cool. And then kind of the next steps beyond that, maybe the next step up of complication is adding metrics. So numbers counting how many times something happened. Monitoring that focuses on metrics includes the Prometheus open source tool and kind of like all those systems like Datadog, AppSignal, New Relic, Scout, who's on all of your water bottles, And then the next step after that is traces, where your application keeps track of how long each request and response cycle takes, and it like keeps track of each thing that happened inside that cycle. And if you've ever heard of open telemetry, that's what this is. And honeycomb.io is the pioneer service company of this kind of traces style of monitoring. But other companies like Sentry and Datadog have also added the ability to collect and review traces using the open telemetry reporting tools. Traces are really powerful. I don't always find honeycombs, we don't do logs, we only do traces, which then what do you do with your logs? Look at them somewhere else, I guess. So I don't always find honeycomb easier to follow along with than just reading the logs, but having traces where the entire cycle is mapped out and you can see every individual thing that happened in the middle is so helpful for the things where the logs don't actually help you figure out what's going on. And there are many times when I've been able to solve problems from traces where looking at the logs just left me I don't actually know what's happening here. So I'm really glad to have it as an option. And Honeycomb also has kind of a great free tier if it's a small personal project, and I super recommend trying that so that you are familiar with it by the time you have a big important production project and you need to know how to use traces to figure stuff out. So last on the topic of errors, the open-ended question to ask yourself is, how will people tell me about problems? Do you have a contact form? Do you have a support email? Do you have a social media profile? Make sure there's some way to hear from your users, because there's always going to be some problem with your app that doesn't set off your monitoring, but still keeps people from being able to use it if you can ever find out that it's broken. So next in that big high-level list is data. Data includes not just the stuff that users have uploaded or put directly into your database. It can include uploaded files, anything you've collected as part of making your application work, and it includes everything that you might need while recovering from a catastrophic server failure. So, server failures range from the extremely mundane, the RAM stick stopped working and now the server can't do anything until someone comes with a new RAM stick, up through the very surprising, the truck hit the power transformer outside the DC and good luck. But they all have the same end state where your server is not there anymore, and now what are you going to do? And if the server is gone, the really big question is can you rebuild your app? Do you have a copy of the latest code? Do you have a copy of a recent database backup? Do you have all those uploaded files saved somewhere where you can still get to them even though the main server is not there anymore? So start with the code. Make sure that you deploy to production through some place for your code to live that isn't your laptop that you dropped in the ocean and now it's gone. Most often that's push to GitHub, deploy through GitHub Actions. That's the low effort, easy path for everybody today. But really the important part is just that the process of making the code live involves a copy of the code ending up somewhere else so that you can get it later if you need it. Make sure you have some sort of backup for the database, right? Maybe daily snapshots is great. Most managed database things will have an option that you can check that's please take a daily snapshot of my database. For my side projects, I built a daily GitHub action that connects to my database and slurps out a copy and saves it as a GitHub action run artifact. I didn't know this until I built this system, but actions artifacts have no size limit. But they time out after 90 days. So this is ideal for emergency backups, actually. No size limits, so knock yourself out. Anyway, test your backups, right? This is maybe an advantage, but also a scary thing of having done this for 20 years. I've watched more than one startup write a very embarrassing homepage post that says, "We thought we had backups. We are now shut down." Have more than one backup, preferably one per day with a backlog or something like that, and actually test that there is data in the backup so that you don't have to write the embarrassing homepage post that says, "We thought we had backups, and we were wrong." And then once your database is taken care of, look at those uploaded files, right? If you use one of the services like S3, B2, R2, all those short 2-letter letter number services, whatever. That can be a huge advantage because all of those services, like their entire pitch is, we will keep 3 copies of anything you give us, which is a great number of copies to have. And I specifically want to call out, if you're doing something small scale, a popular strategy sometimes can be to run a tiny open source min.io server that has the S3 API, but is just a container that you're running connected to a hard drive. And that's fine, but please don't treat that like it's backed up the way actual S3 is backed up. Because if the min.io server crashes, you are now in exactly as much trouble as if you had never had backups of any of that in the first place. So I don't recommend doing that unless you're sure that those are like ephemeral files or temporary files, or you don't actually truly need a copy of them later. And then lastly, for data, you now need to think about how you're going to deal with all of the existing production data, which is now, this is the smallest it's ever going to be for the rest of time. And you can't erase any of it, right? Like if you're working and your laptop schema gets into a weird state, you're just like, I'm going to delete all of this and just try again, schema load. You can't do that with your production database. I'm sorry, migrations are now very hard, actually. So to avoid any site downtime, you need, get familiar with the 3 deploy dance of making changes to your data, where you have to push the code that will handle both the new and the old data, and then you have to push the thing that changes the data from the old to the new, and then you have to push the thing that cleans up all of the code that knows how to deal with the old data. I highly recommend the strong migrations gem or something that fills a similar role to keep you from being able to accidentally not follow the 3 deploy dance of user data. But basically, you just want some guardrails to make it harder to accidentally break either the site or break your user's data. And then, next high-level topic, let's talk about speed. I know some of you are thinking internally, speed from a Rails app? It is possible. In my experience, the biggest reasons that Rails apps get slow are external API calls, responses with no pagination in them, and N+1 queries. And Rails may not be the most performant framework ever in the world in terms of actual responses, but it can be completely usable and serviceable, and all of us are proof that many businesses can be built on top of it, as long as you don't, make a slow external request and return it with no pagination after making 100 separate queries for each record in your unpaginated list. So why does the speed of the application matter? Well, basically, it also comes down to confidence. If your users can see what's happening quickly, they are confident that your app is working correctly. And if your application takes so long that users are just staring at their phone until they forget what they were doing, they don't have confidence. And whatever did happen with, why is this page loaded? I don't know. So speed is also important enough to apply the monitoring and observability tools that we talked about to speed, right? Keep an eye on how long your application takes to do things. Don't use averages. Averages are all lies. Averages don't really exist. That's a whole separate talk, which I have done in the past, and you can look it up, and it's great. But use percentiles is the 1-sentence version of that separate talk. So if you have 10 users per day, maybe watch the 90th percentile, because only one person is having a worse experience each day than the percentile that you're watching. But if you have 10 million users every day, you might want to track the 99.999th percentile, because whatever that number is, at least 100 people had a worse experience than that. And yeah, it's a great example. You can grow your service until you reach the point where the only numbers you actually care about are the 4 or 5 or 6 nines percentile, because that is the number that indicates a large group of people, more people than are at this conference, had some really horrible experience with your app. When you find something that's slow, the main tools to fight against it are monitoring and profiling. Monitoring tells you which users experience the slowness, right? You can say oh, this person saw this very slow request, and usually what they were trying to do, right? It was wow, they tried to do this. This took 5,000 years or however long it took. It might even be able to tell you exactly which SQL queries or which HTTP calls made things so slow, right? Like the New Relic dashboard thing for looking at slow stuff is the thing that always comes to mind for me, but there are a lot of tools that can do this. And then profiling can tell you what code is being run and help you optimize the code itself versus like all of the external stuff. The rack prof gem is like the most well-known profiler for web apps, but there's many options. Datadog just published some interesting stuff where they've been doing like sampling, profiling, but across every Ruby app that sends data to Datadog. Like everyone who has their profiler turned on, to be clear. They're not doing it secretly, but it was a really interesting survey of like across many, many Rails apps, kind of like here's what we're seeing in terms of like how much CPU is spent, what percent is database calls, and all that stuff. Outside of carefully optimizing your Ruby code or paying for really, truly gigantic servers, I also strongly recommend using a content delivery network like Fastly to serve anything that doesn't need to be fresh generated on every request. So like the easy ones there are like all the images, but if you have pages that are the same for everyone, or if you have, especially if you have like larger files, images, videos, whatever, caching a copy much closer to your user is going to make a huge difference in kind of like the perception of how fast your application is. And this is especially important if you have users outside the US, because that means that your data has to go over an ocean cable somewhere before your users can see it. So please make all of the files as small and as close as possible to your users so that they'll have a good experience. And now that you know how to keep your app fast, security is the other like big thing around confidence. So that basically the mental framework that I use while thinking about security is there are two resources to defend. The two resources are user data and the servers themselves, right? The class of attacks that's about user data is we want phone numbers, emails, credit cards, I don't know, whatever. And the other type of attack is about hijacking your servers to do work for them instead of you. And then maybe that's send spam, show ads, mine cryptocurrency. It's like the second class of attack is your server got taken over. So the best defense for user data is just not to store it. If you don't need it, don't collect it, and then no one can steal it. If you do need to collect user information, make sure you're only collecting the actual information that you need rather than more than you need. And if your users are supplying like sensitive information, if it's financial, if it's related to identity, please make sure it's encrypted so that if someone does manage to just like slurp a copy of your database, they still don't know what that data is. It's actually really easy to encrypt a single column in a model nowadays, which is great. It's a huge improvement over the bad old days, so be sure to do that. And then the best tool against attackers who want to hijack your servers is to keep all of your libraries updated, right? Use Dependabot or Renovate or something to apply security fixes so that there's no known, it's the old joke about running away from the bear and you just need to make sure you're ahead of everyone else and you'll be fine. Keep API tokens encrypted or in a secret store, don't check them in, monitor your CPU and disk usage. This one is one that I now think about a lot. Set up a billing alert. If your usage goes up above what you expect, you should probably find out why. Hopefully it's not that someone has broken into your server and is now using it to do things on your credit card. But billing alerts, that's a really good one. So ultimately, it's always worth it to have a security policy, even if it's really simple, just some contact information so problems can be brought to your attention. You don't need a security team and a hacker one and all of this stuff. You just need to know that which stuff could go wrong and how people can tell you about it so that you can fix it. Knowing that you have backups that can't be deleted by someone who breaks into your server is a huge advantage here. I strongly recommend it. So now we're going to talk about lead time. The research project DORA, which stands for DevOps Research and Assessment, has been investigating software teams for many years. They were originally incubated by Puppet. Wow, that's an old Ruby thing. Nowadays, they work in a department in Google Cloud. But the book named Accelerate was written by the founders of the DORA project, goes into much more depth than I can fit here. But I'm just going to talk about one of the 4 core metrics in Dora's research, which is lead time, the amount of time it takes to go from code being committed to that same code being live in production. If you can make a change and get it deployed to production in a few minutes, you are going to have a completely different experience as someone operating an app than if you make a change and you get it deployed in 3 weeks. So the Dora research project found that small lead times is one of 4 biggest predictors of software projects and teams being successful. And just like keep making that smaller, and you are getting closer to being a successful team. So the overall main finding of the Dora research project is that the conventional wisdom of go super slowly and super carefully to avoid having problems is the opposite of what you actually want to do. The teams and projects with the least number of errors and the smallest number of rollbacks and the least failed deploys are actually the ones who deploy the fastest and deploy the most often, because then they get good at doing it and they mess it up less. So if you're already operating a large or slow application in production, the biggest advice I have is to reduce the size of each change and reduce the amount of time that it takes to get those deploys rolled out, to try and make each change as fast as you can. If you're at the beginning of a project, the strongest recommendation I have is just like establish all of the automations that you're going to plan to use as the project grows, and start with, as soon as there's code, it is already being tested and getting automatically deployed. You can use GitHub Actions and modern hosting platforms, and you can just make it true that all code gets deployed 5 minutes after you push it, as long as the test pass. That's a great lead time. 5 minutes, that's awesome. Keep that. Starting to wrap up, the big concerns after you deploy are errors, data, speed, security, and lead time. And the reason that I use those categories is so that I can think about those categories as I'm reviewing proposed changes. Like, is this change going to impact our ability to monitor errors? Is this change going to impact our ability to respond to requests quickly from our servers? Is this change going to impact, sorry to harp on Cloudflare, our ability to roll out configuration changes without taking out half of the internet? These are the categories of thing to think about when you're working on changes or when you're reviewing your coworkers' changes. By keeping those categories of concern in mind, you are now better prepared to operate a production deployment than most Rails developers, frankly, right? Like you're already ahead of the pack. If the thought of working on all of these things was interesting to you, you probably have like a pretty exciting future in DevOps or SRE or something. And if this talk has just filled you with unspeakable dread, I recommend sticking to larger teams where that can stay someone else's problem and not yours. If your team could use a boost while working on all that stuff, I work for Spinel Cooperative with the developers from the teams of, core teams of Rails and Hotwire and Ruby Gems and all those things, and we would love to help you out with this stuff. So chat after the talk or check out our website. But in the end, listening to all of the advice in this talk, will this mean that your app never goes down again? No, I'm sorry, your app will still go down. My app will still go down. It's inevitable, and it's usually because of something that we didn't expect and that's totally outside of our control. And instead, this advice is about being prepared and about having confidence to tackle the inevitable downtime when it comes for you. You'll be prepared to recover from the downtime. You'll be prepared to add protections in the future to try and mitigate that problem. And ultimately, that's the best any of us can do. And so I wish all of you good luck with your future Rails app deployments.